So my USB breakout board has arrived. I'm so excited to test it, and hopefully it works. It would be really embarrassing if I went to the trouble of documenting 2.5 hours of creating this PCB and it had some critical flaw in it. In this video, we're going to document the process of going through board bringup. That is validating a new PCB design to make sure that all the functionality works properly. So we'll take it step by step. We'll do it systematically, and in the end, hopefully, we've got a board that works. I just got my UART boards from JLCPCB. So they come nicely packaged like this. Sorry, I've done some painting, so can't get this paint off. So you can tell they packaged it a little bit more nicely because I did not get the pins soldered in. So my first step here is I've got some pin material, just cut off 4s, and I need to solder these in here. But you can see they came out rather nice. I did realize that I was in a little bit of a rush and I forgot to label like the power LED. I forgot to label the reset button, although I guess it's close to the reset pin. Maybe go back into the PCB and edit that. One interesting thing is there's 2 holes in the board that I didn't put there. JLCPCB added those in order to make it easier to manufacture this. So I'm guessing these are registration holes. And I think there's a way that you can actually put those in yourself if you want to, if it matters where they are. But by default, if you don't include them, they'll just put them in a part of the board that's not terribly important. So we're going to go ahead and solder this up and see if it works. See the back of the board, our flood fill. And I think I'm also going to test this with a high current draw to see how much we heat it up. So that'll be fun to see if this extra work that we did to create a nice heatsink for this linear regulator was actually effective. So it turns out that I got a little bit lucky here through no good planning on my own. I happen to have spaced these 2 pin headers apart perfectly such that they'll fit in a breadboard. So I've got a wonderful way of soldering this. I can put them into the breadboard and I get a nice, good, stable platform to solder to. So I've got this almost perfect little situation here, and I've got my solder iron heated up to, I think, 399 degrees Celsius. I'm going to put some flux in here. I don't know, if you read r/soldering on Reddit, they'll say you can never have enough flux. And I'm a believer in flux. No. I just want to put the heat on the pin, not the solder. Oops, nice big blob of solder there. I think those are passable for winning awards, but they worked. There, now our pins are nicely attached, and we can go ahead and start testing the board. Dead honest, this is the first time plugging it in. Now when we plug this in, we should expect to see the power light come on, and that's about it. So let's hope. Yes, beautiful. So the power light came on. We can test the 5 volts out and the 3.3 volts out. I highly recommend this ZOE. It also is a pretty, I mean, it's an okay oscilloscope. Okay, so to the shell. 5.25 volts. That seems like it's a little out of spec. 5.25, and then we do here, we should see 3.3, that's almost perfect. I think if we go to there, we should see 3.3. If we go to here, we should see 5.25. Yeah. So this board is big enough, you don't really need like test points to connect to anything. One thing we can do is we can give it a little bit of a load test here. It's not the right connector, but it will connect on 3 of the pins here, and it breaks them out. Not to the right colors, but okay, who cares? So, okay, so white is ground, green is 3.3 volts, and red is 5 volts. We want to kind of make sure that that guy doesn't get in here, so kind of push him away. And you can see I've connected up my electronic load, and it's registering 3.3 volts effectively. So I'm going to do set, and I want to just give it a certain amount of load. So let's do 250 milliamps, and go ahead and say on. And the whole board is taking 0.8 watts. So let's see what that means in terms of board heat. That linear regulator is actually getting quite hot. It's about 45 degrees Celsius, which is a non-trivial amount of heat for only 250 milliamps of load. So, you know, this is why people say don't use this. There are much more efficient ways of doing things. But a linear regulator is simple and it gives nice, good, clean power. And hopefully we've done all the right stuff to spread the heat around. You can see the outline of our square, our big sheet of copper, and it is conducting heat quite well. When we flip it over, you can see that nice square, that nice rectangle of copper that we've got in a big hot spot from it, but it's spreading through. So like that hot spot is the heat coming all the way through those vias, getting through this other side of the board. So let's go up to our, what we wrote on the board was 400 milliamps max. 40, 50, our max here is about 60 degrees Celsius, which is getting toasty, but I mean, spreading a good amount of heat around. So I think we're good there. Let's go ahead and take it up to 500 milliamps. Stress test it a little bit. This should be the max of the USB spec. USB shouldn't really deliver more than 500 milliamps anyway. You can see the hot spot there is 62.5 degrees Celsius, 64. We're spreading heat to the back of the board pretty well. That whole board kind of heats up when you pull this much power out of it. 66, it's still heating up a little bit. You can see the polyfuse is getting hot now too, right? We're just kind of at the, I think we're at the limits of that polyfuse. It was a 500 milliamp polyfuse. So, I don't remember. But that's the way it works. It heats up and its resistance increases. I think we've topped out in the mid 60s here. So that's probably just about as hot as it's gonna get. So I think, you know, this looks successful. Like you can use this all the way up to the limit of the USB spec. I've downloaded the very ironically named Silicon Labs Simplicity Studio. It weighs in at a couple gigabytes and comes basically with nothing installed. So you have to jump through some hoops, connect your device and so forth, and then you can program it. You can see we've got this project that it created, and now we're going to go to the Express configurator in here, and we can see the vendor ID. I'm attempting to reprogram it. So I've come in here and I've said Silicon Labs via signal drift. So to change that manufacturer string, hopefully it's the vendor ID and the product ID that really identify it. I think these are just descriptions. There's all these things that you can change in here, transmit, receive, and so forth. We're going to leave those alone. What we are going to do is we're going to change the GPIO 2 and 3 to be TX toggle and RX toggle. And I think that's all the programming we need to do in here. Go ahead and say program to device. Beginning device programming. Reset. Done. Okay. It says that we've programmed it. With this, we've actually verified that the USB connection works because it was able to talk to its own chip on there via its own USB port and program it with this configuration. So we know that whatever we did with the USB connector works. So this is another step in validating this board and that it actually works. So now the next thing we need to do is we need to actually connect it to a microcontroller. I can't see it. That is a very bright LED. Red is 5 volts. So we're going to give it 5 volts via its own VBus connection here. There, so that board actually came on, so we're validating that. So transmit and receive should be red and green if I hook that up right. So I got the red and green here. Okay, so now let's take a look at UART test. Baud rate, let's try UART 0 and pins 0, 0, and 1. I mean, that just seems simpler. UART init, GPS set function. Okay, so connect you back up. Oh, that's interesting. One powers the other. I didn't see that happening. That's fun. So let's go ahead and run that. So now I should be able to, okay, great. So now let's go ahead and connect to our serial device again. Should be powering things. The program should be running. And let's go and connect to GPIO 0 and 1 here. Dev. Okay, let's switch the transmit and receive. Do we even get any garbage on the screen? Oh, look at that. And my little receive guy is working too. Wow. So we've validated that this board works effectively, right? Although we haven't done transmit. It's just flashing away in our little screen terminal here. Oh no, we do see him transmitting. Ha! Ooh, that's blinking nice. It's kind of cool. It meters it out too. Like I'm definitely sending things faster, but it only kind of pulses at a maximum rate. It's a cool little functionality. One of the things that we wanted to test out here is, does our polyfuse work? And I'm not quite exactly sure how to test that out. I can run 5 volts externally from just a crappy little wall outlet. We see I got a power here. And if I short out the ground and the 5 volts, so the white and the red, our light, I think, will go off. Yeah. And all the lights in the house just flickered. That had to have been a coincidence. Yes, that was a coincidence. And the polyfuse is indeed warm. So, I mean, it does appear to be working. It should cut off once it gets hot, but I can't really tell. Maybe if I look at the outlet, is the outlet, it says it's green. Oh, nice. So the little outlet on my, I don't know, it's like a little protected wall switch guy. It turned red when I did that. And my question is it like actually protecting it? I'm not sure how to measure the actual current flow. I guess we could hook up. That doesn't seem to be working. There we go. Okay, so we can see the polyfuse working here. We see a big spike in amperage, and then it goes down. Now, it doesn't go to 0. It goes down to 200 milliamps, 19. Yeah, so this is, as the polyfuse is heating up, its resistance is increasing. You can see that polyfuse is quite hot, so that is hot enough to boil water. But it's working. It's kind of sacrificing itself. And now if we disconnect it, the board comes back on and immediately starts cooling. Wow, rapidly cooling. The polyfuse is working. It allows a little jolt, and then it restricts the current. It doesn't shut it down entirely. You saw it was doing 180 milliamps. So, you know, that's not zero current, but it's definitely not a dead short. We've got our UART test, and I had codecs write up a tiny little mud that's just kind of laughable. It gives a couple different rooms, and you can do some things in the rooms and so forth. So it's just like an interactive UI, or an interactive text user interface. So we want to try and connect to that and see how that goes. And I've loaded this onto our PyPico, and we're going to go back over to the terminal here and run our screen command and see, did we do it right? Well, you can see the TX light is going, but the RX is not, so maybe we've got these reversed. So we're going to do look. You're at a small highway, a draft chills the air. Let's do go north. And you can see our little blinky lights going as we type. Beautiful. Look. It's just gonna, there's nothing more to see here. Go south. Look. Help. Let's see. I'll go say hello. Help me. You say hello, help me. Who? Let's see who's online. Oh, player. Well, let's give myself a name. Name Josh. Who? Okay, wow, it actually has some state. Codex wrote a little bit of game state. Uptime. Great. And you can see our little lights blinking. It's a beautiful thing. And let's exit. Let's go ahead and quit. That's wonderful. I think this thing is fully validated. I don't know of any other functionality that we were hoping to capture here. Oh, that's one thing I wanted to see. I updated this to say Silicon Labs via signal drift. So if I go into system report, there we go. Okay, so if I go into my system report here, USBs. Ah, look at it. My manufacturer is Silicon Labs via signal drift. So we actually did change that. Well, this is the world's worst multi-user dungeon. I can think of so many better ways of doing that. But thank you, Codex, for saving me a half an hour of typing baloney. Oh yeah, we wanted to test reset. So we have this reset unlabeled reset button. Let's just see what happens when we push it. Nothing really happens. Let's go back to our terminal. So now we're connected. Let's see if I hit the reset button. Do we disconnect? Yes, we did disconnect. So that did momentarily reset it. Now we're connected again. Look. Okay. Reset. There we go. So that actually works. Beautiful. So thank you. If you stuck with us this far, you've watched 2.5 hours of designing and making a PCB, and now 15 minutes of validating that PCB design. That's a wrap. We've validated that this little guy works. It does everything that we expected it to do. I hope that you go through the process of actually designing and submitting an order to JLCPCB yourself, and then go through the process of doing the board bring up. I would suggest that you look for opportunities to modify and extend this design. I gave you a number of different suggestions in both the earlier videos and this video. One opportunity would be to add a 5-volt output option. Another opportunity would be break out some of those GPIO pins and explore some of that functionality that you had with the Silicon Labs configurator, which allows you to write and read those GPIO pins using their proprietary drivers. So thanks again for watching.